Hello, I am Flash Isaac, and today I shall be taking you through electrolysis and Faraday's laws of electrolysis, explanations and calculations. Electrolysis and electrochemical cells are very important redox processes. Redox. What is a redox process or redox reaction? Redox reaction is any reaction in which oxidation is taking place and reduction is taking place. What is oxidation? Oxidation is the addition of oxygen. What is reduction? Reduction is the removal of oxygen. What is oxidation? Oxidation is the removal of hydrogen. What is reduction? Reduction is the addition of hydrogen. What is oxidation? Oxidation is the addition of electronegative elements or removal of electropositive species. What is reduction? Reduction is the removal of electronegative element or species or addition of electropositive species. What is oxidation? Oxidation has to do with loss of electrons. What is reduction? Reduction has to do with gain of electrons. What happened in oxidation? The oxidation number increases. And what happened in reduction? Oxidation number reduces. That is the comparison or face-off between oxidation and reduction. So, in electrolysis, there is conversion of energy. Electrical energy is being converted to chemical energy. Electrical to chemical. Meanwhile, in electrochemical cells, chemical energy is being converted to electrical energy. In electrolysis, electricity is being used. Meanwhile, in electrochemical cells, electricity is being generated. In electrolysis, electrolytes are compounds that conduct electricity when they are in molten form or in solution. Or in summary, electrolytes are compounds that conduct electricity when they are in liquid form. While in conductors, electrons, they conduct via electrons. So, conductors are elements. Example, copper. Another example, silver. Meanwhile, electrolytes, they are compounds. So, conductors are elements. Electrolytes are compounds. Electrolytes, they conduct by means of ions. Meanwhile, conductors, they conduct by means of electrons. Electrolytes, they decompose in the process. Meanwhile, conductors, they don't decompose in the process of conducting electricity. So that is the background. Now, what is electrolysis? Electrolysis is the passage of direct current through a compound in solution or molten state with decomposition occurring at the electrode. On the other hand, electrolysis is splitting of a substance or of a compound by means of direct current. And this compound must be in its molten form or solution so that it can be separated into its component ion. The diagram you see here is a typical electrolytic cell. Electrolytic cell is a cell or a setup where electrolysis takes place. If electrolysis is the passage of direct current through a substance to split it into its component ions, then where does electrolysis take place? It takes place in electrolytic cell. This is how electrolysis works. Mechanisms of electrolysis. Now, direct current is passed to the electrolytes via the electrodes. These are the electrodes. And in this case, the electrolytes decompose to form its component ions, positive ions or negative ions. Positive ions are cations and negative ions are anions. So anions, negative ions, they migrate to the anode. Cations, positive ions, they migrate to the cathode. And discharge takes place in the electrodes. That is electrolysis. Now look at something. And the anode is the positive electrode, the positive electric rod in electrolytic cell. This is an electrolytic cell or electrolysis cell. In electrolytic cell, the anode is the positive electrode. But in electrochemical cell, the anode is the negative electrode. So they are reversed. So Meanwhile, in electrolytic cell, the cathode is the negative electrode, while in electrochemical cell, the cathode is the positive electrode. Now, cations in electrolytic cells are positive ions, while anions are negative ions. So I told you electrolytes are substances or compounds that conduct electricity when they are in molten states or in solution. When these electrolytes are in solution, more than one ion is being discharged. So in that case, there is something called preferential discharge. Which of these ions gets discharged? So there are three factors that determine the ion that gets discharged. The first one is the position of the ion in the electrochemical series. 2, the concentration of the ions. 3, the nature of the electrodes. Now, talking about electrolytes, we have strong electrolytes, weak electrolytes, and non-electrolytes. Strong electrolytes, they are solutions that ionize completely. So they are very strong and they ionize completely. These are examples of strong electrolytes. Weak electrolytes, they don't ionize completely in solution. So examples are organic acids and others, as we can see. Now, non-electrolytes, they are compound or substance that don't conduct electricity when they are in molten form or when they are in solution. So these are common examples: benzene, ethanol, and so on. When direct current is being passed, the current flows this way. Now, the direction of flow of current is opposite to that of electron. So if current flows this way, electrons simply flow in opposite direction to current. Take note of that. Now, what are the common electrolytes and the ions that are present? This is very, very important. The first one here is molten sodium chloride. Remember, electrolytes, they conduct either in molten state or solution. Molten state, when they are melted, that means it is the electrolyte itself, the compound itself. While in solution, there is water. And I told you that water, they have their own ions, positive and negative ion, H plus and OH minus. What is ion? An ion is an atom or group of atoms which possesses an electrical charge. So, given molten sodium chloride, the ions present are Na plus and Cl minus. Sodium is plus and Cl is minus, plus 1 and minus 1. Why? Sodium is in group 1, so it can give out just one electron to become positively charged. While chlorine is in group 7, it accepts 1 to be negatively charged to complete its configuration. So the valency, this is plus 1, this is minus 1. Since it is in molten state, the ions present in molten sodium chloride are sodium plus and chlorine minus. Why about sodium chloride solution? This means water is being introduced. So the ions present are the ions in molten state plus the ions present in water, H plus and OH minus. Copper 2 surface solution, CuSO4. The ions present in molten state are Cu2 plus and SO4 2 minus. This is the ion present 2 minus. This is the Cu2 plus. But in copper 2 surface solution, when water is being introduced, OH plus and OH minus are being added. KOH solution, K plus, OH minus, and H plus. But in molten state, it's K plus and OH minus. So on, so forth. So take note of the difference between molten state and solution. Now you may be asked a question. 2 questions. 1, describe the mechanism of electrolysis of molten sodium chloride. This is a hot cake question. What do you do? I won't write, I will explain on your own. Keep taking notes. And I advise that you watch this video more than 5 times, because the more you watch, the more you get info. There are a lot of facts dropped here. Okay? So please do that. Very important. This is it. Now, the electrolyte is molten sodium chloride. Is the electrolyte. Direct current is passed through in step 1, right? As it gets here, it decomposes into its component ion. So given molten sodium chloride, the ions present are Na plus and Cl minus. Cl minus. And the positive ion, cation, goes to the cathode, Na plus. So this is this at the chlorine Cl minus, Na plus at the cathode. Look at something. What happened at the cathode and what happens at the anode? This is where the shortcut is very important. Cryo. What is cryo? Here means cathode. Here means reduction. Here means anode. Here means oxidation. So reduction takes place at the cathode and oxidation takes place at the anode. So the reaction at the anode are Cl minus electron to give you Cl. Cl plus Cl to give you Cl2. This implies that 2Cl minus electron, 2 electron to give you Cl2. This is the reaction at the anode. How about cathode? Electron gain occurs at the cathode. So Na plus gains electron plus electron E minus. Now, what happens? When a sodium ion gains electron, it becomes sodium atom to give you Na. So at the cathode, we have Na, and at the anode, we have Cl2. We will stop here. Why? This is simply because only one ion is deposited at the anode and only one ion is deposited at the cathode. How about a situation where we are asked to solve or find the mechanism of electrolysis of sodium chloride solution, not molten solution? What happens in that case? For sodium chloride solution, direct current is passed through the electrolyte, it splits. So the ions formed in sodium chloride solution are Na plus, Cl minus, H plus, and OH minus. These are the ions present in sodium chloride solution. Remember, the negative ions migrate to the anode. So the negative ions are Cl minus and OH minus. So at the anode, reaction at the anode, Cl minus, OH minus. So the ions present at the cathode are Na plus and H plus. Now, two ions are present. One of them has to be discharged. So which of them will now be discharged? When we have more than two ions at the cathode and at the anode, we look for one to be discharged. And there are three factors or rules that govern the one that will be discharged preferentially. The first one is the position of the ion in electrochemical series. 2, the concentration of the ion. And 3, the nature of the electrode. The ions that are higher in electrochemical series will generally be less discharged than the ones lower. So the ones higher will discharge the ones lower, will displace it in the reaction. 2, concentration matter. When they are closer in the electrochemical series, the one that has higher concentration will likely be discharged or deposited. And nature of the electrode. For some electrodes, they are inert. They don't take part in the process, in the reaction, while some take part in the electrolysis. So this brings us to the next topic, electrochemical series, activity series. These are applications of electrolysis, industrial applications of electrolysis. The first one is extraction of metals. 2, purifications of metals. 3, electroplating to plate materials. And 4, preparation of some compounds. Electrolysis is so important that it can be used to prepare some compound like sodium hydroxide. So these are the 4 major applications of electrolysis. 1, extraction of metals. 2, purification of metals. 3, electroplating. And 4, preparation of some compounds. Now, I told you that in electrolysis, preferential discharge is choosing which of the ions will be discharged out of the 2 that migrate to the cathode or to the anode. Remember the last example we solved? Sodium chloride in solution. What happened? H plus and Na plus migrated to the cathode. OH minus and Cl minus, they migrated to the anode. And I told you that if more than one ion migrates to the anode or cathode, then the reason for preferential discharge comes in. Which of them will be discharged? And I said there are 3 factors. 1, the position in the electrochemical series. And 2, the concentration of the ions. Then 3, the nature of the cathode. Let me explain the electrochemical series. This is the electrochemical series. Here is cations, positive ion. Here, anions, negative ions. At the cation, this is the increasing preference for discharge. Remember that the positive ions, they migrate to the cathode. Anode and cathode are the electrodes, electric rods. This is increasing preference for discharge, meaning this is higher, this is higher. The lower will be discharged. In a situation where you have Na plus and H plus, H plus will be preferentially discharged because it is lower in electrochemical series. For example, the electrolysis of sodium chloride solution, where Na plus and H plus migrated to the cathode. This is the cathode half equation, and this is anode half equation for sodium chloride solution. Now, why is hydrogen preferentially discharged? Because it is lower than Na plus in the electrochemical series. Why? This is the decreasing electropositivity. This is more electropositive than this. There is a shortcut for the electrochemical series of cations. It is popular scientists can make a zoo in thin, low, humid country more satisfactory good. Popular scientists can make a zoo in thin, low, humid country more satisfactory good. So this is K plus, potassium ion, sodium ion, cation ion 2 plus, Mg magnesium 2 plus, aluminium 3 plus, zinc 2 plus, iron 2 plus, tin 2 plus, lead 2 plus, hydrogen plus 1, silver, mercury 2 plus, silver plus, gold plus, iron argentum. So take note of the charge because it is very important while solving problems. Take note of the charge, very, very important. Write them down because we need them after this. Why for anions? This is the decreasing electronegativity, and this is increasing preference for discharge. So meaning, given this and this, the lower one will be preferentially discharged. So there is a shortcut for this. Francis showed no conscience, breaking Irenaeus' heart. OH minus, and take note of the charges. These are ions, an atom or group of atoms that possesses electric charge. Now the second one, concentration of the ions. When you are given dilute sodium chloride solution, I've already told you that hydrogen will be discharged, and at the anode we have OH minus and Cl minus. So OH minus will be discharged because it is lower in the electrochemical series. But in the case where you are told that electrolysis of brine is the electrolysis of concentrated sodium chloride, that is brown. In that case, OH minus will not be discharged because in concentrated sodium chloride, which is brown, fine. At the anode, we have OH minus and Cl minus. But because Cl minus is more concentrated, Cl minus will be discharged instead of OH minus. This is where concentration comes in. The more concentrated the ion is, the more likely it is to be discharged, especially when they are close in the electrochemical series. But look at something else. If you have Na plus and H minus, concentration may not have effect because the distance is very far. It has effect if they are close in the electrochemical series. That is when concentration comes in. So if we are told electrolysis of brine, Cl minus will be discharged instead of OH minus, which was discharged in the dilute sodium chloride solution. Now, if the electrode is mercury, the metal in cathode, and electrolysis of sodium chloride with mercury as the cathode, in this case, sodium will be preferentially discharged or deposited instead of hydrogen. Not because it is lower in the series, but because mercury has affinity for sodium to form sodium amalgam. So that is an exemption. So if you are told that the cathode is mercury, note that because of love of sodium and mercury for sodium to form sodium amalgam, sodium will be deposited or discharged instead of hydrogen. When the anodes are made up of ions that are similar to those of the electrolyte, then the nature of the anode plays a role. For example, silver salt using silver anode, or electrolysis of copper using copper anode. So they play one or two roles. Faraday's first law of electrolysis states that the mass M of a substance liberated at the electrode during electrolysis is directly proportional to the quantity of electricity passed into the substance. So mass is directly proportional to the quantity of electricity. This is Faraday's first law of electrolysis. And what is quantity of electricity? Q is equals current times time. Therefore, Faraday's first law of electrolysis states that the mass is directly proportional to current times time. And remember, in variation and in mathematics, we don't solve with proportionality sign. We change it to equality, thereby introducing a constant. So in this case, when we change this to equality sign, we introduce a constant E IT or Z IT, where E or Z are constants, which is referred to as the electrochemical equivalent. That is Faraday's first law of electrolysis. How about the second law? Faraday's second law of electrolysis states that when the same quantity of electricity is passed through a solution of different electrolytes, the relative number of moles of the elements deposited is inversely proportional to the charge on the ions of the element. Now, when the same quantity of electricity is passed through an electrolyte containing different ions, let's say sodium ion Na+, cation Cu2+, Al3+. Now, the relative number of moles of the ions deposited is inversely proportional to the charge on these guys. Discharge on 1 mole of electron is equals Avogadro's number times 1.602 times 10⁻⁻⁹, which is number of electrons. So if you are given sodium plus, it contains 1 electron. Therefore, the discharge on 1 mole of sodium is Na times 1.602 times 10⁻⁹, Avogadro's number times the charge on electron. When you multiply, this gives you 96500 coulomb. And this is referred to as Farad. That is charge on an electron. Farad is the charge per unit mole of electrons. That is Farad. Now, from the second law, since this is +1, so 1 Farad will be required to deposit 1 mole of Na+. From Faraday's second law, 1 Farad will deposit 1/1 mole of sodium plus. Deposit is also the same thing as discharged. So the substance that is deposited is also the one that is discharged. So since this is +1, this is divalent and this is trivalent. It has 1 valency, 2 valency, and 3 valency. 1 Farad will deposit 1/2 mole of Cu2+. 1 Farad will deposit 1/3 mole of Al3+. Because of the charge on the ion, the more the charge, the less the number of moles produced. For example, sodium ion, 1 Farad will yield 1 mole of sodium ion. 6 Farad will therefore yield 6 moles. Look at cation. Cation is divalent. So 2 Farad will be needed to yield 1 mole of cation ion because it is divalent. While 6 Farad will be needed to yield 3 moles of cation ion. Look at aluminium. 3 Farad. A whole 3 Farad will have to yield just 1 mole of aluminium ion, while 6 Farad will be needed to use just 6 mole. You see? So the number of mole produced is inversely proportional to the charge. As the charge increases, the number of mole reduces. Look at this. This charge is simply +1. You see, 6 Farad is needed to produce 6 moles. This is 2 The number of mole produced with the same quantity, 6 Farad, is 3 moles. the number of moles produced with the same quantity is 2 moles. So the same electricity is passed, 6 farads, and the number of mole is different depending on the charge of the ion. As the charge increases, the number of moles produced reduces. Look at the first question. It says a solution of silver salt is electrolyzed with current I is equals 2.6 ampere flowing for 70 minutes. What is 70 minutes? Time. T is equals 70 minutes. And remember, we saw for time in seconds. How do we convert from minutes to seconds? We multiply by 60. So 70 times 60 is equals 4,200 seconds. Calculate the mass deposited. N is equals question. The molar mass of silver Ag is equals 108 grams, and 1 farad is equals 96500 coulomb. So we are looking for the mass of copper that is deposited. Now look at this. This is current times time. So Q is simply equals IT, and it's equals 2.6 times 4200 seconds, which is 10920 coulomb. So this is the quantity produced. Questions under electrolysis require reasons. Now, what element are we talking about? Silver. And what is silver? Silver is Ag plus. So it has plus 1 ion, or the oxidation number is 1. Because in some questions, you'll be asked to look for the oxidation number or the charge. So the charge on silver is plus 1. Plus 1, what does it mean? It means that 1 farad will be required to deposit 1 mole of silver, because the charge is 1. 1 farad will require to deposit 1 mole. And what is 1 mole? 1 mole of any element or of any substance is the same thing as its mass. So 1 mole of silver contains 108 grams. So therefore, 1 farad will be required to deposit 108 grams, because 1 mole of silver contains 108 grams, which is the mass. What is 1 farad? 1 farad is 96500 coulomb. So this means 96500 coulomb will yield 108 grams. So this question is now saying that what will 10920 coulomb yield? Let it be S. 1 farad will deposit 1 mole of Ag plus, because it has a single charge. If it were double charge, it will be 1/2 mole of the ion. Since that 1 farad with 1 mole of silver contains 108 grams, that is the mass. So therefore 1 farad will deposit 108 grams. And what is 1 farad? It is 96500 coulomb. So 96500 coulomb deposit 108 grams. What will 10920 coulomb? Because that is the charge here. Current times time. What will it deposit? Let it be S. Cross multiplying, you simply have that S is equals 10920 times 108 over 96500. This is equals 12.22 grams. So the mass of copper deposited is 12.22 grams. We may not be able to give, or I may not be able to give all the examples you will see other electrolysis, but look at something that you find very helpful. Instead of this analysis, there is a formula you can use to answer any question in electrolysis. These are the formulas. They are very similar or almost the same. M is equals MIT over QF. What is M? M is mass. What is this capital letter M? It is molar mass. What is current? What is I? I is current. What is T? Time. And remember, IT is equals Q. So you can replace IT with Q. What is this other small q? This small q is charge on the ion. For example, for Ag plus, small q is 1. For copper, it is plus 2. So depending on the charge of the ion, small q changes. What is F? F is the farad. Faraday, 1 farad. So with all this, you simply answer this question. For example, in this case, we are looking for mass, right? The mass of copper. What do? You simply say that mass is equals, molar mass is 108 grams times current is 2.6 times time is 4,200 seconds over quantity of charge is 1, because this is plus 1. If you hear 2 plus, 3 plus, depending on the charge of the element, you put that here, times 1 farad, 96500. Solving that, you get the same answer. You see? So this is the same formula. This is relative atomic mass, which is mass, molar mass. This is mass, the mass deposited or discharged, if you are asked something like that. This is C, charged. So this is something as Q. You can use it as small q or small c. Now, in some questions, you'll be asked to look for the oxidation number. So oxidation number is the same thing as charge. So this is current times farad. Once you are given questions, bring out all your data, do the necessary conversion from minutes to seconds and others if necessary. After that, check all the ones you've been given. The one you are not given is likely what you are asked to look for. You simply substitute, you get your answer. So you can use it to solve hundreds, 200s, 300s of questions in your exam. So let's see the next question. For this question, it says, given the electrochemical equivalent of a metal M2+, the charge is 2+, as 3.6 times 10 to the power minus 3. This is Z, the electrochemical equivalent. Determine the relative atomic mass of the metal M. So first, determine the relative atomic mass. What quantity of electricity will liberate 20 grams of this metal, taking F to be 96500 coulomb? Now, the first part says find the relative atomic mass, and the second part says find the quantity of electricity. Now, in this question, I've introduced a new formula alongside the ones we have before, which is the electrochemical equivalent is equals ROAM over C times F, which is relative atomic mass times quantity of charge times farad. So in this case, we have the electrochemical equivalent Z. So we are looking for the relative atomic mass. It is simply Z, which is given by this, times the charge C times F. So that gives us relative atomic mass to be 65.5, approximately 69.5 or 69.48. The second one says, find the relative atomic mass of the metal. What is the quantity of electricity? So the quantity of electricity is Q. And from ROAM is equals MCF over Q, where Q is equals IT. Making Q subject formula, Q is simply equals 20, which is the mass, we are told, 20 grams, times C, the charge, 2+, times F, farad, or Faraday, over the charge, over the relative atomic mass, which is thought to be 69.48. So that gives us 55,555.55 coulomb. So take note of this formula, take note of this and that. You simply substitute. Now this formula is the same thing as this. Remember I told you that Q is equals IT. And from Faraday's first law, mass is directly proportional to quantity of charge, and mass is equals ZQ or ZIT, where IT is equals Q, and where Z is the electrochemical equivalent. So you can get your Z or I or T or Q from here as well, where M over Z is equals Q, quantity of charge. So I hope you found this helpful. I am Isaac, and don't forget to subscribe if you love what you are seeing. Feel free to let me know how you feel using the comment box. So that is it.